To solve this equation algebraically, what we're looking to do is unwrap the equation so that we have x alone on one side. In order to do this, we need to first isolate sine of x on one side of the equation. So, we take 2 equals 10 sine of x minus 3, add 3 to both sides, you get 5 equals 10 sine of x. You divide both sides by 10, and you get 1/2 equals sine of x. And at this point, you have two options. Your two options are, you can either use an inverse trig function. Here we could say take the arc sine, or inverse sine, of both sides of the equation. And on the right side, you'll end up with x. On the left side, you'll have to evaluate arc sine of 1/2. You can either use a calculator, or at this point, you're going to be asking yourself a question. When you see arc sine or inverse sine, that's saying, for what angle does sine have a ratio of 1/2? And that's really the same thing that this line was saying. Sine of x, some angle x, gives me a sine value of 1/2. And we know what the answer to that has to be. If you look at a unit circle, sine has a value of 1/2 at pi over 6, and again at 5 pi over 6. So x must be pi over 6 or 5 pi over 6. And those are the only two answers we should consider first, because we are told only to give answers for x between 0 and 2 pi. The second half of the question says, what if there was no restriction on the domain? What that's saying is that we can look at any and all coterminal angles to each of these two angles, because sine of pi over 6 should be the same thing as sine of 2 pi plus pi over 6, or not just pi over 6, but 13 pi over 6. So if we were able to look at all possible answers, and not just from 0 to 2 pi, we would want to take all of the answers that were like pi over 6 and coterminal to it, so we take pi over 6 and add 2 pi times some number k, and all the answers like 5 pi over 6, plus all the angles coterminal to it. And here k should be any integer, positive or negative, but it does need to be an integer.